Let's break down the two models that describe how data moves across a network, the OSI model and the TCP/IP model. And we'll do it the way I wish someone had done it for me, with one good analogy, plain language, and nothing we haven't earned. Here's the rule we're going to live by. If I can't explain something to you without hiding behind technical terms, then I don't really understand it yet. So let's earn it. Start with one picture. Imagine you want to mail a fragile gift to a friend across the country. You don't just hand a bare glass vase to a stranger and hope for the best. You write a note to your friend. You wrap the vase and put it in a box. You label that box with their address. You hand it to the post office, and the post office figures out the route. It travels by road, by rail, by truck. And on the other end, your friend receives it, unwraps each layer, and finally reads your note. That is networking. Each layer wraps up the data handed down from the layer above it, like putting an envelope inside a box. That wrapping has a name. It's called encapsulation. And on the receiving end, each layer unwraps its own envelope and passes the contents up. Nobody at the post office reads your note, and you never had to care which highway the truck took. Every layer does one job and trusts the others to do theirs. Hold on to that picture, because now we're going to climb through the layers. The OSI model has 7 of them. The TCP/IP model, the one the internet actually runs on, bundles those same jobs into 4. OSI is the teaching model. It gives us the vocabulary. TCP/IP is the practical one. Same journey, just grouped differently. Here's a trick to remember the 7 from the top down. All people seem to need data processing. All people seem to need data processing. Application, presentation, session, transport, network, data link, physical. Let's walk them, following our package. Layer 7, the application layer. This is the only layer you actually touch. Your web browser, your email, a streaming app. This is the note itself, the thing you sat down to send. When you type in a web address, you're working right here. Layer 6, the presentation layer. Think of this as the translator. Its job is to make sure the data is in a form the other side can actually read. That means encryption, turning your note into a sealed, coded message, and formatting, like how an image gets encoded, sealing and translating the note. Layer 5, the session layer. This is the conversation manager. It opens the line, it keeps that line open while you're talking, and it closes it cleanly when you're done. Like a phone call, a beginning, a middle,
hang up,
and a proper hang up. Layer 4, the transport layer. Now we start boxing things up. This layer chops your data into numbered pieces and decides how they'll be shipped. And this is where 2 big names live, TCP and UDP. TCP is the careful courier. It tracks every single box and resends anything that gets lost along the way. UDP is the opposite philosophy. Just fling it because speed matters more than perfection. That's your video calls, your online gaming. Layer 3, the network layer. This is the address label. This is where IP addresses and routers do their work. This layer doesn't care about the truck route. It only answers one question. Which building does this go to? And what's the best path across town to get there? Layer 2, the data link layer. This is the local handoff. Inside one network, devices find each other using something called a MAC address, the physical built-in hardware ID of a device. Picture the mailroom on each floor, handing the package to the exact right desk. Layer 1, the physical layer. These are the raw roads. Cables, fiber, radio waves, voltages, the literal ones and zeros, traveling as pulses of electricity or light. No intelligence here at all, just movement. Now here's the gap check, the part that tells you whether it really clicked. We just met 2 different address concepts. There's the IP address at layer 3
both are needed,
and the MAC address at layer 2. And if you can't explain why we need both, then we're not done yet. So let me close that gap. The IP address is the destination across the entire internet, like a full mailing address. The MAC address is only the next physical hop, like saying, hand it to the person at that desk, right there. And here's the key. Your IP address stays the same for the whole trip, but the MAC address changes at every single router along the way as the package gets handed from one point to the next. That one distinction, the address for the whole journey versus the address for the very next step, is the thing that trips up almost everyone. Woohoo! Nail that, and the rest of it falls right into place. Now, before you close out the video, let's do one last thing. Let's apply the Feynmann technique to the whole lesson. If we understand this, we should be able to say every layer out loud in one breath, no jargon. Ready? 7. Application, the note you wrote. 6. Presentation, sealing it and translating it. 5. Session, opening the line and hanging up. 4. Transport, boxing it up and choosing your courier, careful or fast. 3. Network, the address label, which building and what's the best route. 2. Data link, the handoff to the next desk right there. 1. Physical, the roads, and the ones and zeros running down them. And underneath all 7, the same idea. Wrap it on the way down, unwrap it on the way up. Encapsulation. That's it. That's the whole thing. If you can say that out loud, you've got it.